Alright, we're in tolerancing again, and I'm going to show you how to use these charts for calculating how much fit needs to happen. We're going to look at the three clearance fit, we're going to look at force fit, and then we're also going to look at transition. And show you how to use these charts here to come up with some of these sizes. So let's look at the clearance fit, which is the RC. There's RC1, RC2, and they have a little, in a machinist handbook, they have all these in there, and I'm going to provide, I provided a PDF of a lot of the fits for you in your topic on tolerancing. It's just sitting there and you can look through it, and it's the same thing I got here. But based on, when to use an RC1 or RC2, RC3, and there's RC, I think 9 that I just used. This is just a sample, and basically I'm going to just show you how to use the chart, and then and it gives a description of when to use these various fits, and a comment you need to, or a statement you need to look at. I'm kind of zoom in a little better. You can see it. Sorry about that. I'm trying to get it focused. Okay. What I need to look at is right here. Basic hole system limits are in thousandths of an inch. All right. So that, this number 0.2, that's written 0.0002. So they're moving the decimal point 3 places to the left. All right. The reason why they only have 0.2 here is just think of all those zeros that would be in these columns and the rows. It'd be so many zeros, it would be hard to read. So they've all you have to do is move the decimal point 3 places to the left. So the 0.2 is written like that. And trying to see another one here. Well, like the 1.1 down here, that is 0.0011. That's how that's written. So it's 1,000ths and 1/10. So 0.0011. All right, let's look how to read this. Now you have a basic size or a nominal size you're dealing with, and let's say your nominal size is 1.5 inches. Okay, and that's why I've got these boxes in here. So you come down to your size, and 1.5 inches fits within that range, doesn't it? It's somewhere in the middle. And again, these are just suggested. You're trying to figure out what kind of clearance you need, and these are just suggested sizes to use, and you can always deviate a little bit. But we're going to use what they have out of the box. Now the first column they have is called limits of clearance. They tell you how much clearance is between the mating parts right here. There's 4/10 clearance. That's 4/10, 0.0004 clearance, and then 1.1 thousandths, 0.0011 clearance. So it's kind of tight. And then that's for that size. And then RC2 fit, if you look and say, okay, I don't want to use RC1, let's use RC2. It's a little more clearance. You got 0.4 and you got 1.4 thousandths. And RC3, if we just keep going, RC3 fit has 1 thousandths clearance to 2.6 thousandths clearance. So there's a little bit more clearance in it. So this is a tighter fit down here. So we'll just use this one as the example. Now for the hole, they say to use this right there, the hole. And the shaft, see, it's broken up into hole and shaft. All right. So you have a hole that you want to use this tolerance to the hole, or this size to the hole and this size to the shaft. This is a negative and a negative, and everything's driven off the basic size. So let me just show, I'll put this up here so you can still see it, and I'll bring this here, piece of paper. All right. So we have our shaft. I always draw a pictorial. There's the shaft, and there's the hole, or the collar, however you want to call it. Put our hatching in there because it's a section view. So there we go. Now for the shaft, they use, so it's 1.5. Get some more lead here. 1.5000 is the basic size, and they say for the shaft you want to subtract 0.4, so you can subtract 0.0004 and subtract 0.0007. All right, so we're subtracting that. I can move back a little bit. So if I subtract 4, I get 1.4996, and I subtract 7, 1.4993. So there's the size of my shaft would be. There we go. Let's stick this in front. Yeah, 1.4996, 1.4993, diameter of that. And they for the hole, it's plus 0.4 and minus nothing. So plus 0.4 minus nothing. So I take my basic size of 1.5, and they go to plus 0.0004 and minus nothing. All right. So it'd be 1.5004 and 1. Sorry, I running out of room here. Let's do it here. 1.5004, 1.5000 is the size of the collar, and then there's the size of the shaft. All right. What is the MMC? Well, the bigger, so this is the M here, and that's the L there. Over here, that would be the M, and that would be the L there. Alright, so step through it again. You got your basic size. The chart says subtract 4/10, subtract 7 off the basic size. That gets you to here. And on the hole, there's your basic size, and it tells you to add 4/10, subtract nothing, and that's what I did here. Now if you look at the MMCs together, you've got 96 in there, so it gives you 0.0004, which would be the allowance, 4/10 allowance, and then you'd have what, 0.7, so it'd be 3, 1.1, 0.0011 is the loosest type of fit. Look at the LMCs together. So what I've done here is I've taken what they've got, I've put it in bilateral or unilateral form, and converted it to limit form. So there's many different forms to put it in, but going back to the chart underneath here, saying they tell you that the clearance is 0.4 to 1.1, exactly what we got. So I'm just showing you how the system works. This is the column I would pay attention to. Okay, but if you had to put dimensions on it for building it, you need to have it in one of these forms, so machinists can read it. So that's how you use the chart. That's an RC. If I go to another sheet here, if I flip it over, it has the FN. Okay, these are the force fits. All right, these are force. FN is force fit. And then it gives you a little description of what FN1 is, and FN2, and FN3, and 4. All right. FN1 is a light drive fit, required, light assembly pressure, so you're probably using a hammer or maybe a small arbor press. And then other ones, you get a heavy drive fits, you got to heat up one, shrink the other, whatever, you get them to fit. And then when they cool to their normal temperature, they become a permanent fit. Again, in the FN, they have the nominal size. They show here in this column how much interference. All right, and then they have the hole and shaft. You just apply those tolerances to each hole and shaft. For in this case, an FN1. There's an FN2. All right, and you say, well, there's an FN3, but there's no. They just didn't have any sizes for that particular nominal range. That's what those are blank for. And remember this right here, that the limits are in thousandths of an inch. The last one, which is the transition fit, I'll show you that. See, this is the LT, which is the transition. Okay, transition fit means at one extreme the part could be pressed together, and at the other extreme they could have a small clearance fit, so they could be either or. So that's why the column here just says fit. It doesn't say anything about interference or clearance. It just says fit, because it could be either or. Could be either or based on whatever size they're made at. Again, they have the same nominal range, and again, they're in thousandths of an inch as well. So, like here's a force fit, and they kind of step you through it. This force fit. So you have a tool plate, and it has a range, a size, and then it has a bushing that's going to be press fit into there. So they kind of go over the MMC, LMC condition. So the allowance, which is a press fit, right? It's a negative allowance. All right, it's almost 2/1000ths press, 0.0019. And the least amount of interference is 0.6. So that part, this bushing has, if you take the MMC, which would be the largest, there's the M, and you take the smallest, there's the M. So you put the two M's together, then you get the 0.0019. And if you take the L's together, the least material condition, you'll get 0.6. So if you make the part within that range, it'll work. So that's a force fit. Here's your clearance fit. Okay, there's your clearance fit. You have a bushing. There's the bushing that we pressed in. Now you have a bushing that goes inside the liner bushing, and that needs to have a clearance fit. All right, if you take the MMC here, which is 750, right, and you take the smallest, 0.03, you have a 3/10 allowance between it. So, and the loosest would be 6, be 8/10 clearance, right? You take 0.6, that's 4, and that's 2. Now it gives you 6/1000 or 6/10 slop. So that's good for a clearance fit. And the last fit to look at is called the transition fit. Okay. If you look at the little, this is again in your book. A transition fit can result in either interference or clearance based on how it's made. Again, you take the MMC, which would be the 6258M. Take the M here, the smaller. Compare them. So it looks like it's 8/10 press fit. That's why it's a negative allowance. And then you look at the LMC condition. You're looking at 9/10 clearance. So that's a transition fit. Could be either way. So those are the charts, how to use them, and so hopefully you understand the difference between clearance fit, press fit, or force fit, or and transition fit.